Hey guys, Mr. Yisley here. Just gonna finish up the last portion of our absolute value equations note. So we've got two examples we're gonna go through. So when you look at these examples, you're gonna notice right away that both sides have absolute value. So I'm gonna show you what you need to do in this case, which, to be honest, is no different than what you did before. You're going to isolate absolute values if you could, but you can't because they're both on there's one on each side, and we want to keep one on each side. All right, so really we're just going to skip straight to step 2 every time, and we are going to set up our two equations. So our first equation, we're going to bring everything down out of absolute values exactly as it is. So first equation here, I'm going to do it just slightly off to the side, of x plus 8 equals 2x plus 1. So that's my first equation. I brought everything down exactly as it is. My second equation, I'm still going to do the same thing. I'm going to bring everything down as it is, but I'm going to multiply the entire right side of the equation by -1. So I've got x plus 8 equals -1 times 2x plus 1. So again, it doesn't matter if there's subtraction symbols inside the absolute value. It comes down exactly as it is. All right, so we're going to simply multiply the entire right side by -1. All right, so let's go back to our first equation. We're going to solve this. So on this one, we've got some pre-solving steps. We don't have any parentheses. We don't have any like terms on one side of the equal sign, but we do have variables on both sides. So we want to go ahead and move those across. So first thing I see is I've got an x on the left side and a 2x on the right side. Well, as we talked about, it's going to make more sense to move it one way or the other. And I see that if I move that x across by subtraction, that's going to leave me with a single x on the right side, so that's what I'm going to do. So I'm going to subtract x from both sides. Well, that cancels here, and then leaves me with positive 8 on the left side equals, well, 2x minus x is just x, and then bring down my plus 1 here. That's going to come down, so I've got 8 equals x plus 1. So now I'm going to go ahead and I'm going to do my to-do undo. Now this is where it's going to get a little different. Before, when we did our to-do undo, it was the same steps for both equations. It's not necessarily going to be the same on both equations this time, so we're going to have two separate to-do undos. So when I look at this, there's only thing going on or happening to the x is they're adding 1. So I'm going to go ahead and I'm just going to create my little to-do undo just to remind myself what I'm doing. They added 1, so I got to do the inverse, which is subtract 1. So there's my work that I need to do, so I'm going to go in and do it. Subtract 1 from both sides, because whatever I do to one, I got to do to the other. Leaves me with x on the right, and 8 minus 1 is 7 on the left. So x equals 7. Now I've got to do that for the other equation as well. So when I do that, first thing I'm going to do, though, is I'm going to use my pre-solving steps. I see parentheses, so that means, hey, got to distribute. So -1 times 2x is -2x. -1 times +1 is -1. Bring down what I didn't use, x plus 8. So we're still using those pre-solving steps that we worked on earlier in the chapter. Second thing, do I have like terms on one side of the equal sign or the other? I do not, but I do notice, third step, that I have variables on both sides. Now, I don't like working with negative variables, so if I can get rid of them, I like to do that. So I'm going to go ahead and say I'm going to move this -2x through addition to that side. So I'm going to add 2x, add 2x. Well, when I do that, those cancel, and I end up with -1 on the right equal to x plus 2x is 3x plus 8. Bring down what I didn't use. All right, so now you see that's considerably different than what we looked at before. So it's going to have its own different to-do undo list. So I'm going to go ahead and make that list, to-do and undo list. First thing I see is they multiplied by 3. Next thing they did was add 8. So I'm going to switch it. Inverse operation of adding 8 is subtracting 8. inverse operation of multiplying by 3 is dividing by 3. So there are my steps to solve. So I'm going to split my equation, and I'm going to go in and solve. So first thing I need to do, subtract 8 from both sides. That causes that to cancel, bring my 3x down. -1 minus 8 is -9. And so second step, divide by 3, divide by 3. So I end up with x equals 9 divided by 3 is 3. Negative divided by positive is a negative. So I end up with x equals -3. Now, much like we did on the previous ones, we now have to go check for extraneous solutions. So I'm going to plug both of those values back in to the original absolute value equation. So into both of those. So I'm going to try to do it as small as possible to save some room. But over here, I'm going to plug 7 in for anywhere I see x. So I've got the absolute value of 7 plus 8 equals absolute value of 2 times 7 plus 1. All right, well, starting with the left side, 7 plus 8, that's 15. So I have the absolute value of 15 on the left equals, well, PEMDAS, 2 times 7. So absolute value of 14 plus 1. All right, well, on the left side, I can go ahead and take my absolute value. So absolute value of 15 is 15 equals 14 plus 1 is the absolute value of 15. And again, the absolute value of 15 is 15, so 15 equals 15. That works, so check. That solution is correct. All right, so then I got to do it on the other side as well. So over here, I'm going to plug -3 in anywhere I see x. So I've got absolute value of -3 plus 8 equals the absolute value of 2 times -3 plus 1. End of absolute values. All right, starting on the left side, -3 plus 8 is 5, so absolute value of 5 equals, right side, 2 times -3 is -6 plus 1 absolute value. Left side, absolute value of 5 is 5 equal to -6 plus 1 is the absolute value of -5, and the absolute value of -5 is 5, so 5 equals 5. That is correct, so boom, both of those solutions work. So my two answers are x equals 7 and x equals -3, and they do work. So just a reminder, when you're doing your assignments, you need to show your check. All right, you've got to show it on absolute values because you could end up with extraneous solutions. So super important, show your work to check. All right, example F, I would encourage you to try that one on your own. So pause the video and then unpause when you're done and check your work against mine. So skipping down to straight to step 2, I need to first create my two equations. So my first equation, bring everything down exactly as it is. So x plus 5 equals x plus 11. Second equation, going to bring everything down exactly as it is and then multiply the entire right side by -1. So I've got x plus 5 equals, I'm going to move this across, there we go, -1 times x plus 11. All right, so now I can go in and solve. So let's start with our first equation. Well, we're going to have pre-solving steps, no parentheses, no like terms on one side of the equation, but I do have variables on both sides. So when I do that, I need to move them across. Well, they're both the same and they're both positive, so it really doesn't matter which way I move it. I'm going to subtract x from this side and subtract x from that side. And when that happens, it causes both to cancel out, and all I'm left with is 5 equals 11. Well, it does 5 equal 11? No, it doesn't. So that means that this portion is a no solution. All right, so that one didn't work. There's no solution that would work for that. So that means I'm going to have at maximum one answer. Well, let's see how the second one goes. So first thing I'm going to do, pre-solving step, I've got parentheses, so I need to clear those through distribution. So first thing I see, -1 times x is -x, and then -1 times +11 is -11. And that's all equal to x plus 5. All right, well now, don't have like terms on one side of the equal sign, but I do have variables on both sides, so I'm going to move them across. Again, I don't like the negative variables, so I'm going to move this x across to that side by adding it. So add x. When I do that, those cancel out. I'm left with negative 11 on the right side. X plus x is 2x, and then bring down my positive 5 that I didn't use. All right, so I got 2x plus 5 equals negative 11. Well, that is something I can solve, so I need to do my to-do to undo list. All right, to-do to undo. And make sure you can see this just fine. Yeah, we're right there, good. Okay, so first thing I see closest to x, they're multiplying by 2. Second thing I see, they added 5. So crisscross. Instead of adding 5, I'm going to subtract 5. Instead of multiplying by 2, I'm going to divide by 2. So there are my two steps. So split my equation right here. Subtract 5 from both sides is my first step. That causes that to cancel. I'm left with 2x on the left side. Negative 11 minus 5 is negative 16. Second step, divide by 2, divide by 2. So I'm left with x equals negative 16 divided by 2 is, well, 16 divided by 2 is 8. Negative divided by a positive is a negative. So negative 8. X equals negative 8. So I came up with the proposed solution. So now I've got to plug it back into the original absolute value equation and see if it comes true. So I'm going to do that right over here on the side. So right here on the side, I'm going to plug it in anywhere I see x. So absolute value of negative 8 plus the original equation was 5 equals the absolute value of negative 8 plus 11. And I ran myself out of room there, so hopefully you can see that. All right, so negative 8 plus 5 is negative 3. So I've got absolute value of negative 3 equals, well, negative 8 plus 11 is positive 3. So I've got the absolute value of positive 3. Well, as we learned about in the properties of absolute value, this is going to come true because the absolute value of negative 3 is 3. The absolute value of positive 3 is 3. So check, that works. So x equals negative 8 is my only solution to this problem. All right, well, again, make sure that you show all of your checking work. I know this has a lot more steps to it than our normal equations that we've been solving, but that's just how absolute values work. And we've got to get this down because you're going to need it later in the school year when we get to the graphing portion of absolute values.